So, bonjour. This is all my French language, sorry. And I am Francesco Guidieri. This is my colleague Sandro Salari. We work for SCP Vision, that is an Italian company based on Eclipse technologies, with special focus on the modeling technologies. And we are here today to present you this new project, new prototype, some ideas and so on. That is an abstraction, a modeled abstraction of a cyber-physical system. So let me introduce you my home. I would like to transform my home in a smart home. And so I need to install some sensor, like alarm sensor, temperature sensor, and so on. And after I need some actuators for the heating system, the Windows automation, and so. And maybe I need some touch display to control my smart home. And I need something to write my policy rules, my own policy rules. This is the problem. First of all, a disclaimer. We strongly recommend to use Eclipse Smart Home project for doing this. We use in our home the Eclipse Smart Home project, and but here we need a simple example for a cyber-physical system. So we will take the smart home as an example. So we could consider my smart home as a complex system where many subsystems cooperate to do things, and where there are a lot of devices spread all over the home, and where devices could be not always connected, but could come and go online at any time. So this is the main scenario. So we have a system of systems. The definition taken from Wikipedia is a collection of task-oriented and dedicated systems that pool their resources and capabilities to work together and create a more complex system. So I can say that my home is a little system of systems. And let's focus on some of them. We have, for example, the heating system, the light control system, the alarm system, and then a home monitor to interact with all these systems. And for each of them, I have many kinds of devices. For the heating system, I have the temperature displays and sensor, the conditioned air, the radiators, and so on. For the light control, of course, we have lights, switches, and maybe a light meter to switch on and off the lights automatically. Then I could have the alarm system with sensor, an outer, and a GSM dialer. And for the home monitor, of course, I need a display, a touch display, and a place where I can write my rules, and maybe an event logger to understand what it happened in my smart home. And for each kind of device, I could have many of them spread all over in the rooms. Okay, take this picture for after. Let's see something about the programming languages and so on. A cyber-physical system is a system of collaborating computational elements that control physical entities. And for each system, I need to write code to make it work. And I can use some languages like Arduino, C++, or maybe Java and OSGI, like in this example. And then I need to connect many systems. And I can use some protocols like MQTT with PAHO and Mosquito project in Eclipse, or other protocols like CoAP with Californium. And maybe I need to face with some gateways, and I can get them from the Cura project with Mihini, I can implement with SCADA, and so on. These are all technologies in Eclipse, in the Eclipse ecosystem, except for C++ and Arduino. But this is a typical Java stack in Eclipse. But I need something different from this. Well, the problem is that I'm not a great low-level programmer. I'm not addicted to Arduino and C language and protocols and low-level protocols and so on. So I need something more high-level to manage my IoT system. I need an abstraction that lets me work with concepts. I need, for example, to design in a visual way the topology of my network. And I need something that is more friendly to write my logical rules. So I convinced myself that I need to model my system of systems. I need EMF. OK, let's see. Here we are. This is our project. That is not really a project. It's a prototype for now. It will become a project depending on your feedbacks and so, and so on. And our project, the idea is to provide an high-level abstraction of a cyber-physical system using some Eclipse technologies. The first is, of course, OSGI Equinox implementation. The second one is the Eclipse communication framework. And, of course, the Eclipse modeling framework. And these, we have some requirements for our system. The first is that the IoT network topology is unknown at any time. And the devices could go online and offline at any time. And another strong requirement is that the device types are unpredictable. So I can't know which are the kind of device that I will use. So each device could have states and function. And we need to access to all devices with all their states or all their function, of course. And then we need to define some logic to rule all device and interaction between devices. These are the requirements. And here, there is the solution. We have, I can describe you the interaction between a device and the system. There are some phases for manage it. The first phase is the discovery phase. When a new device goes online, the system discovers it thanks to Eclipse communication framework. We will see it. Then there is another phase that is the registration, where the new device is registered from the system and an ID is assigned to it. Then there is another phase that is the autodescription, because the device can have to describe itself to the system. And then the last phase is, of course, the model representation. A new model instance is created in the system, and this model will remain synchronized with the device status. So you can interact with the model, and then the framework will manage the change to the IoT network. OK. let's go to the overall architecture of the system. We have two elements. That one is the system, and the other one is the generic device. And we have some technologies here. And in the first phase, the discovery, we have, thanks to Eclipse Communication Framework, we can implement this kind of feature. We will see in the demo. And then there is the registration phase that is made with the OSGI services. And also the same for the auto-description. Here, the Eclipse Communication Framework let us public the OSGI services upon the network, and then we can use the OSGI services to communicate between the system and the device. And of course, the last phase, the model representation, is made on the system with the Eclipse Modeling Framework. Eclipse Modeling Framework is only on the system. Okay. And why we have chosen the EMF? Because Eclipse modeling, of course, let us make an abstraction of the cyber-physical system, as I say. A model represents the IoT network with all devices. And for each device, the model shows the states and the function of these devices. And connection and logic between devices can be defined within the model. And then we have several Eclipse projects that can interact with the EMF model. We can, for example, represent our model with a Sirius project, as we will see in the demo. Or we can distribute our model across a largest IoT system with the CDO framework, for example, and so on. But we can use also model transformation to interact with more complex modeling technologies like MATLAB, Simulink, and so on. So this is why we use EMF. And here we have a little example of how the system works. In the left part, we have my smart home, and in the right one, there is the model representation in memory in the system. And as you can see, when the device goes online, a model representation is created in the memory. And this model will remain synchronized with the status of the devices. And here I can get the first advantage from EMF, because I can reorganize the model as needed. Maybe I want to separate the devices according to the rooms of my home, and so I can organize them in this way. And it is very simple to do in EMF. And this is our model that is very little because it's very generic. We have a generic device with some information like the identifier, the type, and etc. And then the device have a list of statuses, a list of events, and a list of operations. And that's all. We have some primitive types and some status direction, because the statuses can be input, output, internal, or both. And so, as you can see, the model is very generic. It can manage any kind of device. So, it's demo time. I end.
Thank you, Francesco.
Okay.
Okay. In this demo, I will show you a simple network composed of this system is the central, the laptop, and on Raspberry with a temperature monitor, digital temperature AC. And we have two workspaces, one for the central. Then I can start the application. Okay. And we have another workspace for the device. The system is based on the feature of ECF, ECF to implements a distributed system of service that publish service into the network. This work with the feature of OSGI service, and we implement a service using this interface. Each device on the network must implement a iDevice interface, and these are the methods exposed to network. As you can see, we have a get model definition. Then the system, the device send information about its description. Okay, the application is started. Here we can see on the left side we have a custom representation of device. Then I can start a device. Then I do power on this device, and actually the system don't know nothing about this one. There is some time before it's run. Okay. In the same time, I describe you this interface. On the left side, we have a custom representation of this device. This application show a temperature monitor. Then there is a SVG representation of temperature. And on the right side, we have a network representation based on a Sirius framework. And on the right bottom, we have an implementation of property view based on EMF pass relay. Okay. Now, when the system starts, the device discovery is based on OSGI service discovery, because ECF dispatch of the service in the network, and the central device have this discovery, and then discover the service as it is in the same machine. It don't know that the service is distributed about the network. Okay, let's see the interface. Now the interface discover the device. The application discover the device. Okay, we have it now. Okay, now we can see the temperature live. And you live this. We have two temperature. One is updated every 500 milliseconds, and one is sent every 10 seconds. It's like a heat temperature monitor. Okay. On the right side, we can see that the Sirius representation is come up. Then we can see an input state and an output state. At the same time, on the bottom side, we can see the EMF partially property view, and that the model is synchronized with this interface. Then we work, all these interfaces work with EMF model. Now I can start another device, but using a simulated device. I start a device, an alarm device. This device rise an alarm when this temperature is over a threshold, go over a threshold. Okay, I start this simulated device on this machine, but the technology is the same.
Yes, we had some problem in these days with devices in general. My laptop has crashed, and another Raspberry has crashed, and then
we have
had,
some piece of hardware.
And then we had an experiment that is a small, very small Linux embedded system that his name is Arietta. That is an ARM 5 with 250 mega of RAM, but it can't work even. So we have to simulate the other device. So sorry for the inconvenience.
Okay, I'm waiting for the other device.
In fact, this is the second choice of our laptop.
Okay.
The first choice was.
Okay. Okay. Where is it? Device 1, alarm device. Now we can connect, we can create the network and can take the output, quindi then the temperature measurement of this device and connect to the current temperature of alarm device.
The idea is that we can make a link between the two devices, two states of the device in a very easy way, and the data can be.
Now we can see the state of the second device is updated from the temperature come from this device. You can see current temperature on the bottom right. Okay. Now I can try to to push my finger on the device to rise temperature. I need some help, please. Okay, you are hot. Now, the alarm system simply log an alarm. I will show you. Okay. Okay.
Maybe I don't. I have to.
More time, because the temperature is sent every 10 seconds. Okay,
Yeah.
alarm on.
We are.
When the temperature rise 27 degree, the alarm go on, and now, okay, alarm off. When go down.
So we have communication between the two devices on this stack.
Okay, now I can show you what happened when I remove the power of this device.
You had to wait.
My machine is
some moment, some time.
now this device has changed states. Okay, it's off. It's great.
So the state of the device is synchronized with the model, and we can represent it in any way. This is a simple demo. Please consider it as a simple demo, but it works, the communication. Okay. Okay, and then sorry. we would like to talk about integration with other projects because we are interested in in some projects, but the first one is the Eclipse Platform project because we have to write our Java code for the device that is very simple. We need only to know which are the states and the functions that the device provides. And so we can use a code generation, simple code generation to generate the Java code for the device. So we can use the Vorto project to get the information on the device, and then we can generate, for example, the Java code for the device. And another integration could be with the Eclipse Cura project or Mihini project to get a gateway for some other networks, because here in this demo you have seen that we represent a single device. In the same way we can represent also a subnetwork of devices. And so we can use the Cura gateway, for example, to access another network. Also because the Cura gateways is an OSGI application, and so we can integrate our little layer with the Cura, and so on. So, did you power? Yeah. So we are waiting for the device that goes online. Maybe not. Okay, but yes. Okay. Oof. And so here we are. We have. Torna pure sulla presentazione. We have some times for questions, and another thing is that as I said, we strongly recommend to give us feedbacks, because this is an idea, a prototype, not a real project at the moment. And so we are very interested in your opinion about it. And so please use the conference feedback system to give us feedback for the presentation, but also you can talk with us and say, in the slide there are our email, and we can talk about it. So it's time for questions. So, yeah.
Identifying itself, because you can have a huge way of the device, a word, and a lot of sensors, and I think it's a little bit simple to do this like that. But I think the idea would be to have a cloud-based dictionary of devices.
Yes.
You can share among users. So when you discover a new device that is absolutely unknown, you can use the identifier, the unique identifier of the device to describe it to others.
Yeah, this is the common approach of many other frameworks, in fact. But But and we could use other clouds to get information as well. But the real purpose of this prototype is to get a generic representation, because I want to interact with a model, and a model could be very simple, because I need to access the states of the device and the function of the device and the events of the device. And we think that it could be enough for this kind of interaction. But you are right. There are a lot of devices, and could be not enough this approach. Yeah. Another question?
Yes. So you mentioned
Yeah.
Concerning the function, sometimes function can be quite complex.
Yeah.
So how would you formalize it? It's not just a string.
Yeah.
Okay.
Well, we have to manage this function with. I think that as a first implementation, we can manage the function with the primitive types. Yeah.
I think it's more a remark. I think the Eclipse Worker project is trying to come up with these descriptions of functionalities, and there might be a interface to have these projects cross-talk.
Yes, we could use it as for the interface. Yes.
How do you put it? It's called Vorto.
Vorto. Yeah. That is a project that aims to describe devices for doing the code generation for different platforms. For example, for Open Hub or Smart Home, I can get the information and then I can generate the code that is needed to work with some kind of system. And the Vorto project is a modeled repository where we can get the information about the device, how it's made. And so we are thinking to use that kind of information. Okay. Yeah.
Do you think integrating already real-life system and protocols like Z-Wave protocol, which is currently used in many automatics or smart home applications?
Yeah.
And Z-Wave has a different. I think it's the devices are identified by an ID, and the system identifies the device. Then populate information about it. That's not your approach.
Yes, but it's we can change the approach.
Yeah.
We can
Yeah.
the ID, the type ID from the device. Then we go into the network, we download the image, create a model. And this demo, the information to create a model came from the device itself. But it's initially we think this approach. I don't know the more information. This example is more simple to.
The main target remains to have a modeled representation. Yeah.
Can you say how much time you spent on your model definition and your first implementation?
I think.
Someday.
Yeah. Some week.
Of course, it strikes me as really interesting. So the UK government has invested a lot of money into coming up with an IoT standard that does exactly what you just presented. And if I tell you the number, you're going to feel often underpaid.
Yeah.
And I'm quite impressed that essentially with not a consortium, but essentially really just
Yeah.
joint effort between two.
Some individuals. Yeah. Yes, but our ideas was to make a very light layer upon the other Eclipse technologies. So we have used them.
ECF is
Eclipse Communication Framework is the big unknown of the Eclipse projects because we use every day for provisioning with P2, but we don't know. But it's very powerful.
it's abstract the protocol. For example, I not need to use UTT define the autodiscovery on the network. It manages this kind of problem. Okay? It's very important.
Some other question? Okay, that's all. Thank you very much for attending and give us feedback.